Awkward silence. Just kidding. Hi all. Thanks for being here and thanks for listening. Very nice of you to come all here. I'm Jesse. I'm a developer at Lively for 5 years now. And yeah, what we do, we help other companies to standardize and digitize repeating and complicated processes. We build custom web applications for them. And our customers can be just anyone. We work for schools and universities, we work for a law compliance firm, and we even work for the Dutch Army. Well, Lively and our products grew rapidly. We have to deal with more and more complex code every single day. And as the title says, data-driven front-end at scale. Yes, scaling for us doesn't necessarily mean that more and more users are using our products. That is the case, but we are digitizing and standardizing business processes. So it's more that scaling for us means that there's more and more complex code rather than more users. So when I use the word scaling, I actually mean increasing business logic and increasing amounts of code. So this talk is based on that experience of a growing code base. And in this talk, I aim to show you a common problem in scaling code bases and how we solve that problem. I would rather say challenge. And I aim you to offer some inspiration from it for your own stack, because I assume not everyone here uses the stack we use. So let's turn it on. I'm aiming for a specific but a major challenge. And the challenge is from one simple call to a whole application full of them. And yeah, it gets clearer further in the presentation. Let's just kick off with an example. Just take a simple REST API call using the fetch library. When you call a REST resource like /users, well, you probably want to keep the data in memory, so you assign it in a variable and you parse the response as JSON. You will probably want to wrap it in a function so you can call it later when you refresh the data or something. And you will probably add a loading state. I just add comments here because it depends on your viewing layer, something. And it gets more complex and complex every time you add stuff. So in this case, we are adding pagination. So I just created a property page and then passing it through the query parameters in the URL and stuff like that. And then you can pass it as a parameter here. So it gets more and more complex. And you will probably want to add caching. You will probably want to add error states. You will probably want to add an optimistic UI when you're calling a post request or something. And you'll probably want real-time updates using, for example, polling or WebSockets or something like at some point in your application somewhere. So it gets complex and complex and more complex. And this is also for so many use cases, for so many different users using your application with so many different roles using your application. And the pages get deeply nested, and there's going to be written a lot of pages, like hundreds or thousands of them. And well, you can probably imagine how the front-end code base kind of explodes when adding more and more business logic every day. So that's the challenge, because the code example you saw is not acceptable when you're doing that thousands of times. So let's jump to the stack we use. And as I said, it's applicable to all of the stacks you are using. But for now, we are deep diving into our stack and our use case, so you can get some inspiration from it for how to solve this problem or challenge over time. Well, the stack we use, just a tiny little bit of it, is GraphQL and React. It's just a tiny little bit of it. But who of you knows GraphQL? And who of you knows how to use GraphQL? Oh, that's pretty much nice. And about React, how many of you know React? Okay, and writes React? Okay, that's cool. Okay, so that I'm gonna use some quick examples of GraphQL and then a quick example of React to make it clear for the people who don't understand. So let's first start with GraphQL. GraphQL is a query language. You can use it to call a specific query based API, GraphQL-based API. And yeah, it's actually a specification. It's not necessarily implemented in a language. It's language agnostic, but it's implemented in JavaScript, in Ruby, Node, etc., PHP. And well, it's a specification. So an example is this. This is how you query some data, and you can. Here I'm requesting the users field, and the users field is an array, but you don't see it here. But for every user, I'm requesting the ID and the name and the email. And I could leave one of these fields out, and then I won't get that in my response either. So it's a kind of flexible API, more flexibility than, for example, REST. Well, the GraphQL JS implementation would be, yeah, for example, using the fetch that you saw earlier, and that would kind of return a data object like this. So it's just a JSON response with the user's array with some objects with the fields you requested. Yeah, that is if you're using the fetch library. And using the fetch library is a little bit complicated in GraphQL because you will have to, every time you have to say that the method is post, and you have to give some headers and stringify the request, etc. So when you're using GraphQL and JavaScript together, you will probably want to use Apollo. And that's where Apollo comes in. How many of you know Apollo? Nice. Okay. So you're probably familiar with Apollo request of vanilla JavaScript as well. And it would be for the same query would be something like this. So you only have to configure the URI once, and then you can reuse that initiated client everywhere where you want to query. Well, you can add some variables to it, if it works. Some variables. But that's pretty much the API. Well, and the nice thing is it returns a response. And in the response is data and errors and loading state, everything built in right in it. So you don't have to create a loading state yourself or something. So that's nice. And there are some more in the box of Apollo, as you might know, like caching, file uploads, and built-in error handling. So that's Apollo. And let's see how complicated it gets if we put this right in React. So it could look like this. A React component with some initiated state, which is defined in the beginning, and then you assign a response in the load data function, and you put that in the state, and in the did mount you call that same load data function, so it gets called the first time, and then you render components using the state. So you could use it like that, but the thing is, what about pagination? What about real-time data, or refetching with other variables, or merging data from parent views, or yeah, over time you're probably doing this with hundreds of views. So it gets really complicated, and it doesn't really solve that problem or solve that challenge we have from one simple call to an application full of them. The solution to that is a good abstraction layer, a maintainable good abstraction layer. And when you are using Apollo and React together, you will probably be using React Apollo. And before React Apollo had such a nice version as it has today, we wrote this abstraction layer ourselves. We called it Fetcher, and we did multiple things with it, like fetching more data in pagination or matching the loading state in React. So we wrote the abstraction layer ourselves because the need came up. But it has plenty of edge cases we didn't account for, so it was a hard problem, but it was better than nothing to have an abstraction layer. Well, I'm going to show you just the Apollo React example. We are assigning just the same query to a variable, and we are using it in our React components just like this. The query component is imported from React Apollo, and you assign the user's query to a query property, and that's just it. And you will probably want to do something with the results, so just create a function which gets the result as a parameter, and it will pass through that function by the query component for you. And you can access the data from there, and you can do something with it, such as filling a table. But there's more. There's also a loading Boolean. How cool is that? Just on that same result object, reactive for you. So if the loading state changes, the HTML changes for you automatically because it's reactive. So you can use just a loading spinner or something, and you can map over the errors exposed by the result object. So you can render an error text or something, and you can even use the refetch function exposed on the result object using some button with an onclick. You can use pagination with a load more button with the fetch more function. So all of this just exposed on the result object. And even the network status of a request. And you can have polling right built in with some configuration object, which is a little bit more complicated, but that's not the point. And for the people who like WebSockets, you can even use subscribe to more function, which basically lets additional items stream in as you look at the page. And React will make all this data render for you reactively, because it's Apollo and React working together. So this is kind of an impressive abstraction layer. And yeah, let's just do the checklist. It has a loading state, it has pagination, it has a built-in caching because it is Apollo, and the offline mode comes right with it. And the network status is also there. And you have polling, as you saw, you have WebSockets with subscribe to more, you have an error handling and refetching, and this all using the natural React API. So, yeah, maintainable code using abstraction. That's what you saw here, and that's what's important no matter what kind of stack you use. And yeah, it's only since one of the last versions of React Apollo that it became so nice and working very good. Because it also used the React Context API. Maybe some of you know what the React Context API is. It's kind of a new API introduced in React 16, and it allows you to pass properties over multiple levels of components. So instead of passing the properties in every component down to a very far away child, you can use Context API and access it from the child by making a dependency to the parent, something like that. So that's being used by React Apollo. And yeah, before the time React Apollo deployed such a nice version, we wrote the abstraction ourselves, and it doesn't matter whether you use React or it doesn't matter whether you use GraphQL or Apollo. Yeah, it's a maintainability challenge, and yeah, you can help your future self by making that or writing that abstraction layer, either written by you or for you, or with us, because yeah, we are open for hires. You can contact Peter or me, or visit our website. Thank you. Give me some questions. Yeah.
If you have two different components who do the same query
Yeah.
to the same
Yeah.
API, and is it possible to, if one does a refetch or whatever, that the other one also updates?
Yeah, that's actually the case by default by Apollo. So it's very cool to see every single place where you depend on the same query update while you refetch only one of them.
Ah, okay.
So your whole application stays in sync by default. And if you don't want it, then you can configure it per query or in a top-level middleware or in a middleware placed on a separate level in React. So you can configure it yourself how it works. But that's how it works by default. So that's very cool.
Ah, nice.
Yeah.
Yeah, maybe slightly off topic, but I'm just wondering how heavy all those libraries are together, and if you would use it. It's very nice for a greenfield project if you would start anew.
Yeah.
But I'm currently working on a really big legacy project based on Drupal and jQuery.
Yeah.
And there's just one new endpoint and one new module that we have to build, and I'm thinking about maybe using Vue.js or React. Would you recommend using this combination of libraries?
Is your page accessible behind a login or something, or is it public?
Public.
Okay, that changes the factors, because if it's behind a login, then you can kind of preload it or load it once someone logs in. So then loading times are not that of a problem. But if it's public, you should really consider using lighter libraries. But yeah, for us, our applications grew so fast over time in complexity of code and maintainability that the need for nice maintainability is bigger than the need for very super fast web applications. And that's also because, yeah, internet connections for our target users group are pretty nice, and we are mostly creating desktop applications. So that's the case for us. I think our bundled front-end JavaScript for a very, very large planning tool in one bundle for a specific school we are actually building is still just around 500 kilobytes. But that's so many business logic contained in it, and all of this as well. So, and when you're only using Apollo and React, then I think it doesn't get very high. Only think 5 to 10 kilobytes,
Okay.
something.
So on the front end, it seems like it's really easy to get things going,
Yep.
But it does rely on having a GraphQL API.
Yeah, yeah,
So
that's for me
how
the case.
much work is it really to build a GraphQL API on
Yeah.
the back end for, like, you have existing microservices, for example?
Yeah, that's a
Do
specific.
you use
Yeah,
Apollo what's the server?
Apollo-
Apollo server?
Apollo Server is what you could use. Not really necessary, because the GraphQL node implementation itself is good enough. But yeah, my point of this presentation was more like, for any stack, build an abstraction layer for your front-end API calls, or anything that gets complicated in your front-end. And I can answer your questions. And it completely depends on how hard your entity relations are and such things. But GraphQL is a nice API layer to add later on, because it has kind of custom resolve functions you can write, and you can do external API requests in them to serve the client. So it's a nice layer of it's a nice API layer to build afterwards.
And if you don't have a GraphQL API, just a REST API?
Yeah, we do. We started actually with REST, and we have used Meteor. So we have tried several types of APIs. And yeah, it's a good question because our customers often has APIs already, and we don't want to use them because they are ugly, and we are just creating a mobile app, and we don't want to update our mobile app once our customers change their API. So we sometimes build a GraphQL API layer in between to be able to just deploy directly when they deploy something, to be compatible with our mobile app always, for example.
But then you
You
have
had a
access
question?
to their database.
Yeah, you're just basically proxying their API with another API.
Ah.
Yeah.
Did you ever use the React with the Redux and Apollo together?
We don't use Redux because of this nice new React Context API, which is another way of thinking than Redux, but it is an alternative to using Redux. And I personally think Redux is a lot of overhead over learning React and over maintaining your code. The concepts of Redux are really nice, but yeah, Apollo has built-in relay, and that's basically the same idea, the single source of truth for data. So Redux wouldn't add that many value for us.
But did you ever try to merge your client states? Because I know that when you use Apollo, Apollo has inbuilt store. So when you fetch anything, it has it stores everything inside it like you do it in Redux earlier. But when you have a client state,
Yeah.
you need some state on a client side also. So there may be a case you want to merge these two states, like you want to maintain a client state. I'm just talking about a big application where you actually need a client state.
Yeah.
And then there is a Apollo state which comes out of the box. Then you end up with two states. So either you need to merge them or use Apollo state in a manner that you can maintain
Yeah.
the client state inside it.
Yeah, I think they expose their API to use your own store if you don't want to, and then you will cancel out relay at a whole. So you can just access of you can just use their API when, for example, a specific return object changes, and then you can update your own state, and then Apollo won't use relay anymore. I think.
So you can have one store for the whole
So
application.
yeah, and that will then be a store created by your own. I think that's possible. Good question. Someone else?
How do you use the context API of React in conjunction with the Apollo client? Do you use the context API to store this data?
We use the context API is actually, I'm going back now. The context API is actually exposed by React Apollo. This query component is a consumer component in the context API concept. And there's also a provider component placed on top of your API level, which actually fetches the data and provides the data to the consumers you place somewhere in your application. So React Apollo uses the React Context API to provide the data.
It's like Apollo provider, right? The higher order component,
Yeah.
right?
Yeah.
Can you also do server-side rendering in this setup?
It's always a question. Nice. Yeah, there's a big topic of server-side rendering in the Apollo documentation, and we haven't needed it just yet, but I know there's a lot of attention on it, and I think that it's okay, but I can't really answer your question. Yeah. Nice.
Well, thank you.
Thanks.